Well guys, this is another question related to moments, principle of moments from May-June 2018, paper 1-2, question 13. In the question, it is mentioned that there is a diving board supported by two pivots at P and Q. The pivots are in a shape of rods. One rod is situated up the board. Second rod is situated down the board. The whole board is a uniform board. It means there must be a center of gravity where a force mg, the board's weight, is acting in a downward direction. And at one corner R there is a diver standing. Alright, so this diver must have obviously some weight. Now with this situation, with this whole situation, they are suggested that the whole board is in equilibrium. Now the diver started moving towards P and Q, slowly moving towards P and Q. While he is doing this, the board remains in equilibrium. So what is happening at the forces acting at P and the forces acting at Q? Well, number one, he is not asking the direction of the forces, but let me tell you for the addition in your information. When in this situation we have a person standing at one corner of the diving board and the diving board is supported by two pivots, there must be a reaction acting at the pivot. Now the pivot located in a down direction, so there must be a force acting in an upward direction, which is a reaction at Q, and there is a reaction at P. These are the two forces, although the direction of forces are not required in the question, but I have just mentioned it for your clarity of concept. Now he suggested that the object starts moving, this person starts moving towards Q. What is happening at the forces at P and the forces at Q? If the whole board remains in equilibrium, if something is in equilibrium, for example, like we are considering since the principle of moments, so like clockwise moment, let's say x is, if remains equal to the anti-clockwise moments, then the whole system will be in equilibrium, right? So now imagine this person started moving towards, let's say, Q, and I am imagining, okay, since there are two pivots, so let's say first imagine there is a pivot at Q. I'm not considering the pivot at P at the moment, because whenever we are trying to solve the principle of moment, we have to use a one pivot and look at the forces, how their forces are acting in the surroundings of that pivot. So if this is the pivot, then an mg is acting in a downward direction, a w is still acting in a downward direction with some constant distances, right? And there is only one force acting in an anti-clockwise direction, which is at P. Now mg still fixed, the person R is moving slowly towards Q. So what happens? The distance between Q and R will be reduced. So now moment is actually the product of force and the distance traveled. So if distance decreases, overall this product will decrease, right? So it means if this R is going towards Q, while this already has a constant contribution of moment, but this person's weight moment will reduce. So overall the combined contribution of clockwise moment due to the weight's board and the person's board will start reducing. ये reduce करेगा, right? Now if clockwise moment will reduce, in order to maintain the equilibrium, if a clockwise reduces, the anti-clockwise has to reduce. Now the anti-clockwise is between P and Q. The distance we cannot alter because it is fixed, so it means the force acting at P must also decrease. If the person starts moving towards Q, the force at F must be decreased in order to maintain the equilibrium. That's the situation for a force acting at P. Now come towards, say, I'm considering the pivot at P now. So there is a force F acting in upward direction. Again the same person is moving, right? Overall, when the person moves towards P, the overall moment will decrease. So it means the anti-clockwise moment, now this time because of Q, should also decrease. The distance we cannot alter, so this force F over here will, it means, sorry, this force F over here, it means has to decrease. So it means both the forces at P and Q will decrease if the person moves towards the pivots. Okay, thank you.